So I welcome you to the lecture series on practical image processing using OpenCV Python. And today our topic is how to find contours, draw contours in OpenCV. Look at both of the images. This is the input image, the first one, and parallelly this is the output image. So now you have understood that what actually we are going to find or what actually we are going to draw. Well, myself, Dr. Bora. So let's start today's class. First of all, we have to understand that what is contour or what are contours. So let's go through the definition. Contours can be explained simply as a curve joining all the continuous points along the boundary having same color or intensity. So what is contour? So contour is a curve which joins all the continuous points. Do remember I'm saying continuous points. Okay. Contour is a curve which is joining all the continuous points along the boundary which have same color or intensity. So why we need to find contour? What is the purpose of it? So the contours are a useful tool for shape analysis and object detection and recognition. So maximum times for detection of objects and recognition of objects, we use contours. Now, for better accuracy, we use binary images. So before finding contours, we need to apply threshold or Kenny edge detection. And about the threshold detection and about the Kenny edge detection, you'll find my lectures on that in one of some means previous lectures, and in the playlist you'll find those lectures, and I'm giving the link in the description box below. So in OpenCV, finding contours is like finding white objects from black background. So in OpenCV, so we need to find contours means what? We are actually trying to find white object from black background. So remember that object to be found should be white and background should be black. That's why I'm saying that we use binary images. Now, how to find contours of a binary image? These are the codes to find contours of a binary image. You can take a screenshot. Import numpy as np, import cv2 as cv. Import numpy, you know why we are using numpy. Okay, obviously we are going to deal with some matrix. Then import cv2, of course we are using OpenCV. Now import matplotlib.py plot as plot. You may or may not insert this one. Okay, if you want to plot, then you can insert, or otherwise you can just ignore or skip this line. Then im cv imread, this is the place where my image, that is contour1 jpg, is located. So I am providing the path to the image, input image contour1 jpg. Okay, so that is being stored in im. Then now I am going to convert it into its gray version. For that I am using imgray is equal to, imgray is the variable where that gray version will be stored. So cv.cvt color, this is the function, and parameter parts are im, that is the input color image, comma cv color underscore bgr to gray. So cv, we have a function that is color underscore bgr to gray, bgr to gray. Okay, that will convert the color image into its gray version, and now we are storing it in imgray. Then red trees equal to cv.threshold image gray 127 to 55 0. And I hope you all know that what actually we are doing for these statements. Obviously we are trying to threshold the image. Now contours comma hierarchy equal to cv dot find contours trace, that is the thresholded version, comma cv retr underscore tre, okay, tree, that is comma cv sane underscore approx underscore simple. So these three parameters are passed to the function find contours. Okay, so you have seen that there are three arguments in this cv.find contours function, and obviously the first one is the input image. Okay, that is the source image, and the second is the contour retrieval mode. So the second argument, that is cv and retr underscore tree. Okay, this is the contour retrieval mode, and the third is the contour approximation method, and this is very important. Okay, the third one is very much important. Now, what we'll get as an output is the contours and hierarchy, and contours is a Python list of all the contours in the image, and each individual contour is a numpy array of xy coordinates of the boundary point of the object. Now you have understood that why we are using numpy, because each individual contour is an array xy coordinates of the boundary points of the object. So I hope this function is clear to you. Now, to draw the contours, we have found out the contours. Okay, through this means cb.find contours, we have found out the contours. Well, that is okay. Now we need to draw them, isn't it? So how to draw the contours? To draw the contours, we will use cb.drawContours function, and it can also be used to draw any shape provided you have its boundary points. Now its first argument will be a source image. Second argument is the contours, which should be passed as a Python list. And the third argument is the index of contours, useful when drawing individual contours. And if you want to draw all the contours, you just need to pass -1. And remaining arguments are color, thickness, like them. So first I am writing, see, three different ways. Okay, you can take any one of them. So to draw all the contours in the image, what we need to pass? -1. So cb dot draw contours image contours that we have found out using find contours function, -1 all the contours, then 0 to 55 to 0 to 3. Okay, and then all the contours will be drawn. Now to draw an individual contour, say fourth contour, so 0, 1, 2, 3, fourth contour. So what we need to pass? cb draw contours image contours. See, I am not now passing, I am not passing -1 now, I am replacing it with 3. Okay, for the fourth contour. Now, but most of the time we use this one. Say cnt contours 4, cb dot draw contours image cnt 0, 0 to 5503. Okay, so the others argument 0 to 550 and 3, I hope you have already got. They are actually denoting the different means other parameters like color, thickness. Okay, so these three ways you can draw the contours. Now, contour approximation method. You have seen that this is the third argument in the cb.find contours function. Actually, why we are using it, actually what it does denote. Okay, so we told that the contours are the boundaries of a shape with same intensity, and it stores the xy coordinates of the boundary of a shape. But does it store all the coordinates? This is specified by this contour approximation method. So if you pass cv.chain approx known, all the boundary points are stored. But actually, do we need all the points? For example, if you find a contour of a straight line, do you need all the points on the line to represent that line? No, you just need only the two endpoints of that line. This is what this cv.chain approx simple does. It removes all the redundant points and compresses the contour, thereby saving memory. In the next class, I will show you the practical implementation. Bye bye.